Okay, so in our last video we talked about the third degree polynomial approximation. And so now these things we've been working with are actually called Taylor polynomials, these approximations. And so now we're going to talk about the general Taylor polynomial of degree n. So we begin by saying let f be a function that is n times differentiable at x equals a. In other words, we can compute the derivative over and over that many times at x equals a, as long as at that point. Now, it could be other values where it may not be, this derivative may not be defined, but we can at least compute it n times, and it is defined at x equals a. Then the Taylor polynomial of degree n, p sub n of x, is f of a plus f prime of a over 1 factorial x minus a plus f double prime at a over 2 factorial times x minus a to the second, and then so on, the third one, the fourth one, all the way up to the nth derivative evaluated at a divided by n factorial x minus a to the n. Okay. Or in terms of a sum, we could write it as p sub n of x is equal to the sum as k goes from 0 to n of the kth derivative of, so the wrong way, kth derivative evaluated at a divided by k factorial times x minus a to the k, where of course we think of 0th derivative as being just the function itself. Right? First derivative, second derivative, and so on, all the way up to nth derivative. But the 0th derivative would be the function itself, and then remember that 0 factorial is defined to be 1. Okay, so everything works out so that this just produces that same sum. So that's the abbreviation, where remember that k factorial means we're starting with k multiplied by k minus 1, and then k minus 2, and so on all the way down to 1. All right, so that's called the Taylor polynomial of degree n. Okay. Now, if a is equal to 0, so in other words, we're centering our polynomial around the point a equals 0, okay, then this polynomial is called the Maclaurin polynomial. Maclaurin polynomial of degree n. Okay, this is called the Maclaurin polynomial. Okay, so this is the Taylor polynomial. And it's just an extension of what we have already developed with the third. The reason it becomes a factorial is if you had x to the n and you started doing the derivative, you'd first multiply by n, then you'd multiply by n minus 1, then n minus 2, until you eventually get down 3 times 2 times 1. Right? So that's where this factorial part is coming from. Right? So you might remember when we did it with the third degree, right, we had to do the derivative 3 times. It was 3 times 2 times 1 times the constant. So the constant ended up being, right, the derivative, in that case the third derivative divided by 6, or 3 factorial. Okay? So that pattern actually just continues as we keep taking derivatives. And so this again is called the Taylor polynomial And again, when we plug 0 in, it actually is a special case of a Taylor polynomial known as the Maclaurin polynomial.